Here we go. Okay, so this is a review of learning how to simplify radicals, since we didn't really learn that last year in Algebra 1, so we're going to learn it in geometry this year. So group the following cards by equivalence. So we have at the top here some radicals that we need to simplify, and we're going to do it in 2 steps. So we'll start with square root of 48. So the way we do these is we break up the 48 into we figure out what the largest perfect square factor of that number is. So perfect squares, what are perfect squares? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. Exactly. Perfect. What's the largest perfect square that goes into 48 evenly? And these are your choices. So, is it 36? Is it 16? Is it 25? Is it 9? Which of these is going to match with the square root of 48?
16.
Because 16 times 3 is 48. Okay. Now the square root of 16, the reason we broke up 48 into 16 times 3 and not like 6 times 8 is because now 16 is a perfect square, and we can take the square root of that and pull it out from under the radical, and that's what simplifying the radical is. So what's the square root of 16? When we take that 16 out of the radical, what's that?
4.
4. So this is just 4, and then the 3 is under the radical, and it can't go anywhere, it's got to stay. This is 4 root 3. So that's right here. How are we doing? Okay? Does anyone remember learning this last year at all?
Sorta.
One person said sorta.
Matt.
You never saw it before? It's fine. It's fine. Okay. Square root of 50. Which one?
25 times 2.
25 times 2. Square root of 25 is 5. So this is 5 root 2. How are we doing? It's definitely easier in geometry than Algebra 1 because your brain is like developmentally ready for it. Square root of 54. How are we going to break that up?
Square root of 9 times 6.
Okay. Square root of 9 is 3. So that's 3 root 6. And then 72 is 36 times 2. 6 root 2. Okay. Matching is much easier than when you have to do it by yourself. We're going to do that by ourselves in just a second. Any questions? Moving on. All right, I'm gonna need that next slide in just a second here. Now we're gonna review how to multiply radicals. We're gonna need this in just a minute. So first we're gonna learn how to multiply the square root of 10 times the square root of 8. I'm gonna go back a slide so I can write. Square root of 10 times square root of 8. We could actually multiply what's under the radicals there, and we'll get the square root of 80. Now we have to simplify this 80. What's the largest perfect square that goes into 80? So first, we may have trouble with that. Let's go ahead and write our perfect squares. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. I don't think anything above that is going to go into 80.
9 times 9 will equal 81. So that's why.
It is, but this is an 80.
I know, so we can't get it.
It would be 8 times
Okay,
8.
I see where you're going with that. All right, so sometimes how do I say this? We want to make sure we find the largest perfect square that goes into 80, not just any perfect square, because then it's more work if we have to simplify it, and I'll show you how in just a minute. Does 25 go into 80 evenly? You've got a calculator. Okay. Does 16 go into 80 evenly?
Yes.
What's 16 times what is 80?
5.
So I'm going to rewrite this 80 as 16 times 5. Then when I take the square root of 16 out, that's going to be 4 root 5. Here is what happens if you don't recognize that 16 is the largest perfect square that goes into 80. You might say, oh, 4 is a perfect square and it goes into 80. Yes, it does. 4 times 20 is 80. But now we have to break up the 20 because 20 has a perfect square factor. 20 is 4 times 5. So not a problem. We just rewrite it as 4 times 4 times 5. And here's our 16, we take it out, we get the same answer. But there's more possibility of error here, and a lot of times people just write this as, they pull the 4 out as a 2, and they say 2 squared of 20, and that's actually not completely simplified. So it's better to find the largest perfect square that gives us a number. Okay, so that one is 4 root 5. Let's go to the next one. 6 square root of 2 times square root of 5. Okay, so 6 root 2 times square root of 5. Now, this is a 6, and this is actually, it's not a 2, it's a root 2, square root of 2. So we can't multiply those together, but we can multiply the square root of 2 and the square root of 5 together. So we can rewrite this as 6 times the square root of 10. Now, does 10 have any perfect square factors? 2 times 2 is 4. 3 times 3 is 9. Do 4 or 9 go into 10 evenly?
No.
Then we're done. Es completo. All right, vamos a ver a la... I don't even remember my Spanish anymore. A la tres problema número tres. All right. Before we do number 3, we're going to review a concept. What is the square root of 2 times the square root of 2?
Square of 4.
Square root of 4. Excellent. And the square root of 4 is 2. All right. What about, what's the square root of 3 times the square root of 3?
Square of 9.
Square root of 9, which is 3. So we actually don't even need this step. What is the square root of 15 times the square root of 15?
15.
Boom. We're going to need that. There's your answer. Next problem, 4 root 11 times 3 root 11. 4 root 11 times 3. Well, 4 times 3 is 12. And what's root 11 times root 11?
121.
Well, remember we skipped that step? What's root 11 times root 11? It's just 11. So this is 12 times 11. And then you guys, somebody said the answer. What's 12 times 11?
32.
So that's what you typed in. Good. Last one, 5 root 13 squared. 5 root 13 squared. What that means is 5 root 13 times 5 root 13. That's what that means. This is 5 root 13, 5 square root of 13, the quantity squared. So we can multiply the two 5s and we'll get 25. And then what's root 13 times root 13?
13.
13. So this is just 25 times 13, which is, you got Desmos, right? Excellent. Excelente. Vamos a ver a la próxima página, por favor. Rationalizing the denominator. Okay, I'm going to show you this video. Always an ad for Grammarly. Do I need that sound? I don't even think I need sound.
Faster. Powered by over 1.
No, I don't need sound. All right, so now the last concept that we need to learn, phone should be away, okay, is when we have a radical in the denominator, okay, for the next couple years, you're gonna need to know how to rationalize the denominator. It's very, very useful. We were actually just using it in pre-calculus this morning. And in higher math, sometimes you actually have to rationalize the numerator, get rid of the radical in the numerator, depending on where you're going with your math and what you need to do. But it's a skill that you need to have in your tool bag. And we learned it in Algebra 1, and we're reviewing it now in geometry. Or maybe we didn't learn it in Algebra 1, it's fine. So we just learned that when I multiply the square root of 3, if I were to multiply that by itself, what do I get? What's the square root of 3 times square root of 3? 3. So if I multiply this expression here by the square root of 3 over the square root of 3, which is equal to 1, and I call this special 1. Okay, this is a special 1. It's a 1 because it's a number over itself. What happens is the denominator, we get rid of the radical in the denominator because root 3 times root 3 is just 3. But we can't just multiply the denominator by a number. We also have to multiply the numerator by that same number. So when we do that, we know how to do this now because we can multiply root 2 by root 3. That's root 6. So right there, 12 times root 6 over 3. We're almost done. We can't divide this 3 into this 6 because that's not a 6, that's a root 6. But we can divide this 3 into this 12 and it goes in evenly. So we're just going to simplify it. That's it. We just rationalize the denominator. We got the radical out of the denominator. Okay, so now we are going to do one problem and then I'm going to stop my video. 7 over root 2. 7 over root 2. What am I going to multiply by? What special 1 can I multiply by to get rid of the radical in the denominator for this problem?
2 over root 2.
So the denominator is just going to be a 2. And this is 7 root 2 over 2. Now, we're almost done. We need to check and see if it's simplified. Does 2 go into 7 evenly?
No.
And we're done. You know what? I just decided we're gonna do one more because I want to make sure we can know how to simplify. Oh yes, 30 over root 10. This is a great one. 30 over root 10. What's a special 1? Yep. So that's 30 root 10 over 10. Can this be simplified?
Yeah.
Because 10 goes into 30 evenly. So it's just 3 root 10. Are we good? I just taught you an entire unit of algebra in 13 minutes.